In simplifying complex fractions, we have two methods. If we have one fraction over one fraction, and there's nothing added on bottom or subtracted, then we can just keep, change, flip. When we're dividing by a fraction, we can keep the top one, change it from dividing to multiplying, and flip the bottom one. But this will only work one term on bottom. If we have more than one term on bottom, then however you try to do keep, change, flip will not work. It has to be exactly one term. So in this case, we can do that. If we have a factor of 6x on top and 6x on bottom, those cancel. 5 goes into 5 once, and 5 goes into 15 3 times. So we're left with a 3 on top, a 1 on bottom, which is just 3. So that's not so bad. Now here, we have two terms on bottom. We have something plus something. So if we were going to do it like we did the previous problem, we would have to combine these and make them into one term. We would have to get a common denominator, add those fractions together, and we don't really want to do that. So the other approach is to multiply the top and bottom by the same thing. If we multiply the top and bottom by the same thing, anything divided by itself, remember, makes 1. As long as the top and bottom are the same, that makes 1. And if we're multiplying by 1, it doesn't change how much we have. It just makes it look differently. So we're wanting to pick something specific so that when we multiply the top and the bottom, it makes our denominators go away. The thing that makes this a complex fraction is that our fraction has a denominator on top. And in our fraction, we have a denominator on bottom. So if we can make those go away, then we can make this where it's not a complex fraction. So we have to ask ourselves, what are we going to multiply by? Well, to make this x go away, we would need to multiply top and bottom by x. Notice if we multiply that by x, and that one would cancel. We also have to multiply that as well. Well, that will make on bottom, when we multiply this by x, that will make that x go away, but it doesn't go away. So we also have to multiply by a 7. So we're going to multiply top and bottom by 7x. Now, hopefully when we do this, we'll see why 7x. 7x is our least common multiple. If we look at this denominator and that denominator, 7x is a multiple of x because it's x times something. 7x is a multiple of 7x because it's that times 1. So if we do the first term times 7x, not a problem. It wasn't a fraction to begin with, so that doesn't help us or hurt us. And then we're going to do the next term by 7x. So 7 over x times 7x. Now the reason we're wanting to multiply by the 7x is so that we can make that x and that one go away. Sometimes I like to put this one over 1, the one I'm multiplying by, to remind myself that's on top. So if I have an x on top and an x on bottom, those will cancel each other. If we look at the denominator, we're going to do x times 7x. That doesn't make anything go away, but we have to do that because we have to multiply everything by the same thing. And then we're going to multiply that by 7x. That term also times 7x. So since we have a 7x on bottom, a 7x on top, those cancel. So what does that leave us with? For the first term on top, we have 4 times 7, so 28x, minus 7 times 7. On bottom, we have x times 7 times x. Well, x times x is x squared, so 7x squared. Then we have 3 over 1, or just 3. So by multiplying by the 7x, that 7x was able to reduce with the x to make the x's go away, and it was able to reduce with that 7x to make that denominator go away also. So when we got through, that denominator went away, that one did, so now we don't have any fractions on top, and we don't have any fractions on bottom. So it's no longer a complex fraction. Now, if that reduced to any, we would want to reduce it, but this one is not going to reduce. All right. This one is back to having one term on bottom. Well, there's a subtraction here. There are two terms. But what I mean is we have one fraction, nothing is added or subtracted to that fraction. Also on top, one fraction, nothing is added to or subtracted from that. So we can just keep change flip. We can keep the numerator. We can change from dividing to multiplying, and we can flip the denominator. So we have an x plus 1 over 5. We have 20 over 2x minus 1. So we can reduce. 5 goes into 5 once. 5 goes into 24 times. Now we can't reduce anything else because this 2 is part of a term, so we can't use it to reduce that 4. This x is a term, so it doesn't reduce here. That 1 is a term, so it doesn't reduce. So we're left with a 4 on top times an x plus 1, and on bottom we're left with a 2x minus 1. None of those factors are the same, so none of them will cancel. And that's as far as we can go. No need to multiply that out. Okay, let's take a look at this one. This one has two fractions on bottom, so we're not going to keep change flip. We would have to rewrite that as one fraction. We can only flip if it's one fraction, not if it's two different fractions. So instead of keep change flip, we're going to use the other approach, that is multiply top and bottom by something that clears our fractions. So this is kind of like when we solved equations and we cleared fractions, except we're clearing fractions on top and bottom instead of on left and right. So if we look at all of our denominators, we ask ourselves, what can we multiply by that would clear every fraction? Well, if we only multiply by an x to the first, that would clear out a fraction like that. But an x to the first wouldn't clear out that all of those x's. It would cancel one of those, but we would still have an x on bottom. So the most x's that any denominator has is 2x squared. So we want to multiply by x squared so that each denominator will go away. So on top, both terms get multiplied by x squared. The first one times x squared, and the second one times x squared. On bottom, same thing. First one times x squared, and then the second one times x squared. And notice again, I'm putting each of those x squareds over 1 just as a reminder that the x squared is on top, is in the numerator. So I can see that that x will cancel one of those x's because that's on top, that's on top, that's on bottom. So we're left with 2 times x. Here we have an x squared on bottom and 1 on top. Those cancel. That leaves us with a 3. Here, those cancel, leaving us 4. This cancels one of those, leaving us 9x. That doesn't factor, that doesn't factor. Nothing will reduce because everything that looks like it might reduce is a term or part of a term. So that's as far as we can go. So it's simplified because we don't have fractions on top or fractions on bottom. Okay, let's do this one. One or two terms on bottom, so we're not going to keep change flip. So what can we multiply by to make this denominator and that one go away? 1y is not going to be enough to make that one go away, but y squared is enough. It would make that one go away. It would also make that one go away. So we're going to multiply everything on top by y squared. And everything on bottom by y squared. So 1 times y squared is y squared. This y cancels one of those out, leaving us x times y. On bottom, this y squared and that one cancel, leaving us x squared minus y squared. So we've simplified it. We have made it no longer a common fraction, but we do need to see if this fraction reduces or not. On top, both of those have a common factor of y. If we take a y out here, we have one left. If we take a y out here, we're left with an x. On bottom, this is a difference of squares. So remember, a difference of squares factors whatever is being squared minus whatever is being squared, and the same things with the plus in the middle. We don't have any factors that are the same, but we do have factors that are exactly opposite. This factor is the opposite of that one. And we saw in earlier sections that opposites reduce to make -1. Anything divided by its opposite makes -1. So those are opposite factors. Cancel them. That leaves a -1 either on top or on bottom. So y times -1 is minus y or negative y. And on bottom we have the x plus 1. Nothing reduces here. This y is a term, so we can't use it to cancel that y out. So we have to stop there.